Friends gathering around the table, eating good food, drinking. That's a scene that we have all been thinking normal, right? But that's not true for many people in this world. Because of climate change and war, we have 800 million people in the world starving and 2 billion people having access to contaminated water. But there are a lot of people willing to help in many different ways, helping through emergency or during everyday life, side to side with local communities. I'm Vito Palladino, and I've been spending my fellowship working for CAFOD, the Catholic Agency for Overseas Development. CAFOD is helping people in need in many countries in the world, and is acting through tackling poverty, enhancing education, and challenging emergencies. These are all very expensive tasks that CAFOD has to support. And the main income for the charity is fundraising. But this is a very complex business. Actually, the 70% of CAFOD income is coming from single donors, more than government or church or any other income. So now let's imagine a war, like in Syria here, where we have millions of people displaced. This is an emergency, and we need to act. So we need to provide food, we need to provide drugs. But what are the questions for a charity like CAFOD? How much money I can put in this emergency? Who will be willing to help? And these people will be donating for the future. So these are some of the questions I've tried to answer during my fellowship. How I did it? I was using a data set of 400,000 donors between England and Wales, and 2.5 million donations that these people have done to the charity. What I've done is to use donations of the past years. Here you have in the y-axis the amount of all the donations through the years, so on the x-axis, and try to predict the future. How I did it? I did implement two different approaches. One is a standard approach that is using 3 features. And this is what the majority of the analyses are doing in these cases. And then I did a lot of feature engineering, and I used machine learning, in particular light GBM, in order to match and get a more complex approach. So once we have these 2 approaches, we have to test them. And what I did is to compare them with the real values. Here you can see the real values of donation between 2015 and 2020. And let's see how the standard model approaches. The standard model approach is quite far off, and you can see how the true values are respect the standard in this slide. At the same time, let's see what the machine learning approach instead does. Here it is. You can see how better the machine learning is performing respect to the standard approach. So the story is not ending here, because this is a complex machine and it's not easy to use for many people. So what I've done is to develop a dashboard, and here you can see the screenshot of my web page, where you can input new data in the first block. Then you can define the past and the future for training and forecasting periods, and then finally predict the single donations and save them on a CSV file. In conclusion, what I've done is to show that my machine learning approach is more accurate than the standard approach, and also that our predictions are at 10% error on a window of 5 years from now. At the end, what I've done is also to develop and deploy an easy-to-use dashboard in order to keep this prediction up to date in the upcoming years. This model is already in use, and a lot of donors, a lot of people at CAFOD are using this to get a better segmentation of the donor's audience in order to reduce marketing expense, and also a better definition of the core donors has been applied. All this will be kept up to date with my dashboard. Thank you for your attention, and I wish I want to leave you with this sentence that I've been reading all days in these 6 weeks. Thank you very much.